the smaller to the larger.
Mm-hmm.
So the preference here would be this, but I'll just say that this creates kind of an unusual inequality situation here at the end. So we'll look at that in a moment here. So that's 10d minus 32. You'll add 32 to both sides.
Mm-hmm.
Let me get a little more room here. So you get 30 greater than or equal to 10d, divide by 10, divide by 10, 3 greater than or equal to d. So this is correct, but not
Mm-hmm.
preferred.
Okay.
And what I mean by that is you wouldn't see this on the answer key. It would be flipped to this direction. Now the arrow still points at the D like that, but this is what you would see. That, you know, this would be considered correct here.
Yeah.
Okay, so let me give you a different distributive property problem, because the ones that I'm seeing that generally students struggle with would be something like the following. Again, I'm going to send you this as a PDF at the end, so if you don't get it all down, don't worry about that too much. But here is like a distributive property problem. Let's say it's 2 times 4x minus 3 minus 5x plus 7 greater than or equal to 2. Okay, so the first one is the first thing here is kind of like what you just gave me. You're going to distribute that 2 into both terms here. Could you work on that and tell me what the result is when you distribute that in?
Yeah, so it would be 8x for the
Got
first
it?
part, and then -6.
Good. Perfect. Now this next one, and you end up seeing this on standardized tests a lot. This negative, this subtraction here, it distributes to both.
Yeah.
And one way you can think of it is that it changes the sign. You can also think of it as -1. It doesn't really matter to me. What matters is what you want to interpret it as. So however you want to do this, the result is minus 5x minus 7. Now my question to you is like, is it better to see that as plus negative here, and then it's like -1 times 5x plus -1 times 7? What do you kind of see when you do a problem like this?
Yeah, I think the plus -1.
Okay, so that means you're going to have to write this little additional step here and then multiply into both.
Okay.
It still produces the same thing. It's the minus 5x plus the -7. And then we're just bringing those terms down here. So here's the step where we need to combine like terms. What are the like terms that you see in this problem?
Is it the -6 and the -7, and then the 8x and the 5x?
Yeah, -5x.
Yeah.
That operator goes with it. It's really important, really important. So yeah, how do you combine 8x minus 5x?
You would subtract 8x from, or
They're already on
yeah.
the same side of the equation.
So would you multiply 8x from -5x?
So let me rearrange it. So this is good that I'm seeing this. You can rearrange, meaning like you can just change the order here. It's 8x minus 5x minus 6 minus 7. Notice I haven't done any math operations. I've just rewritten it. So now you can combine these two terms here, 8x minus 5x. Yeah. What does that become?
Would it be 3x?
Good. And then you've got -6 minus 7.
-13.
Good. Okay, what's the next thing to do here to solve this?
Would you combine -13 and 2?
Yes, but how do you do that? You have to move. And when a teacher or someone says move, you're generally either adding or subtracting.
Okay. Yeah, would you add -13 to 2 then?
So you got to be careful. You would add 13 because you're undoing what what negative 13 is, a subtraction by 13. You undo it with addition. What you said, and I'm not trying to be critical of you, but you said add negative 13, which is a little bit different than adding 13. So you just undo it with the opposite operator. So if it's subtracting like it is here, you would add to undo it.
Okay.
So that gives you 3x greater than or equal to 15. Divide both sides by 3, and x is greater than or equal to 5.
Yeah.
Any questions on that?
No, I think that helps. Yeah.
Okay. All right, let's look at another problem here. Let's go 5 times x plus 2 greater than or equal to negative 3x minus 8. So just another inequality here, and we'll work through this together. What do you see here? What's kind of the first thing you would think to do to work through a problem like this?
I'd combine the 5x and then the 5 and the 2.
You would distribute the 5 to the x and the 2.
Yeah.
Is that right?
Yeah.
Yeah. Okay, so let me know what that becomes. Go ahead and work that out.
Would it be 5x plus 10?
Good. Okay, how about the next one there?
You would do negative 3x minus 8.
So that negative has to go to both, okay? And the first one's really positive. We don't write the positive, but it's really positive. And then it goes to the second one here. Now, you told me in the previous problem, you're like, all right, I'm going to change that to plus -1, like this. And then you're going to take that -1 and multiply it by each of them.
Okay.
Now again, like, it doesn't matter to me, but you have to be comfortable with this.
Yeah.
You have to be comfortable with, okay. And that's why I like the word change the sign. I don't know if that resonates with you yet, but it 3x is positive, so it becomes minus 3x. Subtract by 8 becomes positive 8. That's what I'm really asking here is like, what do you see? And you said I like that plus negative thing. These are just conventions to help you work through the problems. You can choose whichever one you like to work through.
Yeah, so if there's like a negative, it would change the signs for both. So like the 3 is
Exactly.
positive, so it becomes negative, and the 8's negative, so it becomes positive.
Exactly. And if there was another term in here, it would just change that one as well.
Okay.
Figured it out, so it's right.
Okay, so from here, you have to decide whether you're going to move the minus 3x over to the other side or move the 5x over to the other side. And if you recall, I said it's best to move the smaller to the larger.
Yeah.
Which is smaller, positive 5x or negative 3x?
Negative 3x.
Yeah, and it's because it's negative. Like if this was negative 13x, we would still consider it to be smaller. So how do you undo subtraction?
You would add, so you'd
Yeah.
add positive 3 to it.
Yeah, perfect. So that's 8x plus 10 greater than or equal to 8. What would you do from here?
Add 8x to 10.
Those are not like terms.
Oh,
So what
okay.
makes them not like terms is one has an x, one doesn't.
Okay, so would you subtract 8 from the 8x?
What you want to do here is you want to isolate the x term. Okay, and what that means is you want when you're whatever you do here, you want to get 8x by itself. So what you're doing to get 8x by itself is you're undoing this plus 10. So how do you undo addition by 10?
Subtract 10.
Subtract 10 from both sides. All right, so that's what clears it. You can see that they cancel. They're opposite, meaning they undo each other. You got to be careful with some of that language, but what is 8 minus 10?
Negative 2.
Good. And divide both sides by 8 here. So x is greater than or equal to, can you tell me what this reduces to as a fraction?
Negative 4.
That would be 8 divided by -2.
Would it just be positive for them?
So it definitely is negative, but it's a smaller number on top than on the bottom. That's why it's a fraction. So notice you can divide both of these by 2,
Mm-hmm.
and it becomes
1/4.
1/4.
Okay.
Common mistake you just made. I mean, it's
Mhm.
if it was multiple choice, it might be there. So we got to be careful with that.
Okay.
Okay. All right. So I'm detecting a few things here. This is good. Let's I almost wonder if they just snipped in these problems and then they're just not giving you the multiple choice on there. Okay, let's look at a few more inequality problems. So these are this is from section 5.1.
Mm-hmm.
Oh, and by the way, do you need to turn this in for homework, what you sent over, or is it just for review?
Yeah, so it's like so if you finish the whole packet, it's like extra credit. So
Okay.
I'm just
So
doing.
so let's do some of them, and then you can always I'll try and point out how to do the others. But let's look at 124 here. Let me these are some inequality problems here. Okay. Actually, I don't like the way this is written. So let me write here. D minus 5 less than or equal to 1. So this is kind of a simplified version of what we've been doing in the previous problems here. Your goal here is to isolate the variable. I mean, you're a basketball player, right? That's what I heard from mom. I mean, you know what an isolation play is then.
Yeah.
You and the ball, one other player, go for it. Your goal here is to get D by itself. So you look and you're like, what else is going on here? And you should say subtraction by 5. And so my question to you is, how do you undo subtraction by 5?
You would add 5.
You would add 5 to both sides. Okay.
Mm-hmm.
So D is less than or equal to 6. Now there's a bit more that this problem asks for. It says to graph the answer, the inequality. Okay, so assume that you have a number line here, and like as a student, I know you probably want to put a 0 in, and that's fine. 1, 2, 3, 4, 5, 6. Here's 6. Do you know whether it is a open or a filled in circle?
Filled in.
Why? What about this inequality? Go ahead, sorry.
Because it's equal to.
Yeah, that little piece on the bottom there.
Yeah.
So now do you know whether you're shading left or right, and why?
Is it right because it's positive?
Okay, so before you answer, sometimes what you can do is you can take a number on either side. Like let's take 4.
Mm-hmm.
And you put that into the inequality here. And you ask yourself, is 4 less than or equal to 6? Is that true or false?
Less than or equal to. That's true.
That's true. So we want to always shade the true side.
Mm-hmm.
Which means in this case, we would shade to the left.
Okay.
Okay. Now, similarly, we'll grab a number over here like 8. This will be the false side. Is 8 less than or equal to 6?
No.
That's false.
Mm-hmm.
Okay, so the idea is that the number you choose should give you a true statement.
Okay.
When you test it. And that way, because in the multiple choice, you're going to get both of these.
Mm-hmm.
You're going to get shaded to the right and shaded to the left, and you're going to have to choose between them.
Okay.
All right, so let's look at 125 here.
Mm-hmm.
T plus 9 less than 8. Okay, so your goal here is to get the variable by itself. You want it to be isolated.
Yeah.
What can you do to isolate it?
Subtract 9 from both sides.
Exactly. So T is less than, and what number goes there?
-1.
-1. So in these inequalities, and I don't know how your tests will be different, but you always want the variable on the left.
Yeah.
Like it reads better.
Mm-hmm.
And that's just a preference here. So now we're put a number line down. here's 0, here's -1. Is it an open or a filled in bubble there at -1?
Open.
It's an open.
Yep.
And so you have to choose now. You have to say, okay, do I shade left of it or right of it? Okay. And you can always test a point, but here's the reality. If it's less than or equal to, you always shade left. And if it's greater than or equal to, you shade right.
Okay. Okay.
But we can test a point to make sure.
Mm-hmm.
But it gets maybe a little bit awkward here. Like, let's say you were to test like -3. I'll just write
Mm-hmm.
this down. We know it shades to the right. It's like, is -3 less than -1? Sorry, I shaded the wrong way. That was terrible. Is this true? And you got to be like comfortable with that. It's like, well, what does that really mean? This is true,
Mm-hmm.
but maybe that's uncomfortable. So I didn't ask you yet, but do you know if you get a note sheet or a reference sheet?
To like bring to the test.
Yes.
Yeah, you get like a note card you can fill in front and back.
So this might be the kind of thing to put on the note card.
Yeah.
Anything that you don't think you can figure out clearly between now and the exam, and you can start with a much bigger page. You can start with a full page of notes, and you'll realize by the time the exam comes around, you know most of it.
Yeah, I'll write that down right now.
Okay.
Okay.
Any questions on anything we've done up to this point?
No, I think I'm good.
Okay, so we're now going to move to section 5.2, and we now need to talk about when to flip the inequality.
Okay.
Do you remember from class when you flip this one to the one on the right, or this one to the one on the right, or vice versa?
Isn't it when you divide by a negative?
It's actually multiply or divide by a negative.
Okay.
Which means that you got to be on the lookout for these things.
Mm-hmm.
This is something you'll want to also maybe think about putting down on your test.
Okay.
Okay. So let's actually we'll do 127 first, and then we'll sometimes I do problems out of order because there's a kind of a nice natural learning that I want you to have that these problems don't give you.
Okay.
What is the math operation between the 5 and the z?
Multiplication.
Okay. And how do you undo multiplication?
Divide.
Divide. So you divide both sides by 5. Do you know if you get a calculator on this test?
Yes.
Okay. So if you have that or need to use it for this problem, please go ahead. We're trying to replicate, the exact exam experience.
Okay. I'll be right back.
Okay. Sounds good.
Okay, I'm back.
Awesome. So go ahead and use your calculator. Go ahead and do that division.
Okay. Is it negative 12.125?
No, this one works out really perfectly. Maybe just had something in your calculator already.
Negative 90 divided by 5?
Yes.
No, it's not coming up.
What kind of calculator are you using?
TI-84.
Okay. All right. So let me grab mine here with, I've got a digital version here. I'll share it real quick and just see what's going on here. There's a couple of things I can do to help you out here with that. So give me just a moment.
Okay.
get that pulled up. You'll use this calculator more when later in the course and future courses, but all right. So let me go ahead and share this other screen here. So if you ever had any questions about your calculator, definitely be able to help here. So if you're seeing my screen, all I'm asking you to do here, use the negative, which is below the 3, 90, and then divide by 5. And it sounds like you're getting something else besides that. Is that right?
Oh no, now I got it.
Okay.
I think I
Okay.
had something in it like before. I didn't hit clear.
Yeah. So it's always a good idea to clear it out before you do it. You know, I was going to have you change your memory if there was another show. Okay. So let's go back to the other screen. And if you have, if you ever have any questions or calculator, please let me know. All right. So my question to you is, did you multiply or divide by a negative?
No.
No. So the inequality does not change.
Mm-hmm.
Does not change. And that's what you have to literally ask yourself these questions like, did I do that? Okay. Because that is the only justification for changing the sign.
Okay.
Okay. So let's look at 128 minus 13m greater than 26, negative 26. What is the math operation? What is keeping m from being by itself? And what is the math operation between that number and m?
Negative 13 is multiplying by m.
Right. So you undo it with division. And if it hasn't been made clear to you, you use this fraction bar. You don't write the divided by symbol anymore. Okay. Now you can put this number in your calculator if you need to. You can do it by hand. Doesn't matter to me. I want you to get the right answer. That's what's most important.
Yeah. That'd be 2.
Be 2. Now, question to you: did you multiply or divide by a negative?
Yes.
Okay, so that changes this. So I showed you that up here. The less than goes to a greater than, a less than or equal to goes to a greater than or equal to. There's no like diagonal switching here. Yeah. So it becomes less than 2. So it doesn't matter if the number above is negative. It matters what you did. It matters, did you multiply or divide by a negative?
Yeah.
All right, let's go back and look at 126. So here's how it's written, and give you a couple options here about how to interpret it. Actually, that's not very good. Okay. So what I want you as this math student here in the future, what I want you to see is that it's really minus t over 12 greater than or equal to 6, or t over negative 12 greater than or equal to 6. I don't want you to see this negative sort of floating. You know, it's like when you're playing basketball and you don't want to be floating between two guys. You pick your defender. So it doesn't matter to me which kind of appeals to you on the right here. Which of these two options?
Probably the negative 12.
On the bottom here?
Yeah.
Great. So we'll go with that one. Okay. So my question to you, just like before, is what is keeping t from being by itself? What is going on with this fraction bar and this negative 12?
It's dividing.
Dividing by negative 12. So how do you undo division? You multiply by negative 12 on both sides.
Yeah.
Okay. Okay. Now, if that's clear to you, is it clear that these cancel?
Yes.
If it's not, I heard a little hesitation there. If it's not, I mean, you can write this. You can write minus 12t over minus 12. But when the number is the same on the top and the bottom, you do eventually have to cancel them out. So that's the whole idea. Like we don't, in the previous steps here, we didn't like say, oh, it's 1 over 1. We said, oh yeah, these clear out. And that's what you have to be able to do here.
Yeah.
So t is greater than or equal to, well, actually, let me take that back. Oops. Go ahead and multiply those two numbers together.
Negative 72.
Okay. And same thing here. Did you multiply or divide by a negative?
Yeah.
So you have to flip that inequality here.
Yeah.
Okay. So let me give you one like 126 here to try.
Okay.
Just to see where you're at here. Did you have any questions on that though? Sorry.
No.
Okay. Okay, so let's see if I can, let's go 4 less than or equal to t over negative 3. So I've made this one a little more difficult, but I just want to see if there's enough understanding here that you can manipulate this. But take a minute here and see if you can work that out, please.
Okay. So when it's t over -3, you would have to multiply -3 since it's dividing.
Yes, you multiply both sides by -3.
Okay.
Absolutely.
Okay.
So what I'm looking for here, and I do this occasionally, I want to know what goes in this box. Like I want you to work it out completely and give me your like final answer.
Okay.
Just tell me what would go in the box here.
So I did -3 times t.
Is that your final answer?
Oh no,
Okay, wait. Go ahead and keep working it out. This is your chance to to impress me here, which we'll say gently that I'm just looking for you to work this out on your own, just to see what your understanding is at this point.
Okay. So the final answer would be -12 is greater than or equal to t.
Is this how you wrote it?
Yeah.
Okay, so that is correct, but it would not be presented that way on your answer sheet.
Yeah, on the other side.
Yeah, it would be like this: t less than or equal to -12.
So how would you flip it over to the other side again?
So well, you've learned this probably in a previous course, but the direction of this arrow, I don't know, Pac-Man thing, it still has to be pointing at t. So see how the arrow there, or the some people say the mouth. I don't. I'm sorry, I don't really get it, but it's the pointy part. Like the pointy part should still be pointing at the same thing. Like it's over here on the right, it's pointing at the t. On the left here, it's pointing at the t. So as a few examples here, we'll look at that. Let's say it's x. I'm sorry. Let's say it's -3 greater than x. Can you rewrite this for me using that same approach?
X is greater than -3.
Like this?
Yeah.
Okay. Yeah, that's correct. Good. Okay, let's look at 129.
Okay.
And by the way, the lessons are about 50 minutes long. Just in case you didn't know how long we're going.
Okay.
And I'll talk to your mom or dad about that at the end, but we've got plenty of time here. I saw some absolute value problems. It's somewhere in this thing, but I'd like us to finish 129 and then we'll see what else you got here. Okay. Is this right? Yeah. K divided by 5 less than or equal to -17. So how would you solve this based on what you know?
You would multiply 5 by both sides, the k.
Okay. Very good. So grab your calculator if you need to. Let me know what you come up with.
Okay. -157.
Try again. I don't think you cleared out your calculator.
Okay. -242.
Okay, so I'm hearing a lot of numbers that are not correct. So let me go ahead and grab the calculator here again and show you on my screen. So if you're seeing my screen, always clear that out if you need to. So it's -17. Now there's a couple of options here. You can do parentheses 5 like this. The calculator knows to multiply like that, or you can do times 5.
Okay.
I'm not sure what you were doing differently. It doesn't really matter.
I think I was hitting the like minus sign next to the 6.
okay. Yeah. So that you have to somehow mentally say, okay, that's the negative. The subtraction is over
Okay.
here. And like you practice because there's a game coming up. We're practicing right now because you got an exam coming up, and it's okay to make these mistakes right now because maybe you didn't know, or you didn't think to ask, or didn't care, and now you're like, all right, I know what to do.
All right.
Negative, negative, negative. All right, so let's go back to the other screen, and what is that number that goes on the right side over here?
No, negative 85.
Okay. Now my question to you is, did you multiply or divide by a negative?
No.
No, so you don't change it. Any questions on that?
No.
Okay. All right, so let's talk a little bit about absolute value. I saw this earlier in section, I guess 2.5. It's kind of related to all the stuff we've been doing, so that's why I'm going to throw it out there.
Yeah.
Now, are you working on these problems like in class by yourself? Is the teacher helping you? Do you have a friend group you're doing it with?
No, we just do it by ourselves in class.
Okay, it's just solo. Just he's like, hey, you got time today to work on this. Okay. All right, so let's look at a problem. Let's say I give you something like this, like x minus 3 equals 4. Okay, do you remember how to work this out?
Yeah, you'd add 3 to negative 3 and add 3 to 4.
But what about these vertical bars here?
Oh, you have to do the problem twice, a positive version and a negative version.
I like the way you said that. That's actually, I've not heard that in a while, and that's really good. So when you say positive, I assume you mean this.
Yeah.
And then what is the negative version?
You put a negative 4.
Exactly. So you actually have to solve both. Sorry, my screen is not responding for the moment here. Technical problem. All right. X minus 3 equals negative 4. Yes. Now, like you said, you can you undo subtraction by 3 by adding 3, and you really want to solve them simultaneously because it's always the same step.
Okay.
So can you give me the final answer here on the left and the right, please?
Yeah, x is less than
Well,
7.
we're not doing any inequalities, just inequality.
Oh, x equals 7.
Good.
And then on the right side, x equals negative 7.
So it's negative 4 plus 3.
Oh, negative
Negative what?
1.
Yes. Good. Okay. All right. Yeah, I'm okay with that. Let's look at some graphing stuff now.
Okay.
Let's look at 3.1, if that's okay.
Okay.
All right. So let me tell you what I tell all the students taking this class when they get, because again, I'll try to look for that previous thing that students have sent me over the years. Do you see how there's 2 problems for section 3.1?
Yes.
Okay. And you probably have been told like your final is like 40 or 50 questions, something like that.
Yeah.
So they're not going to give you every single question on here.
Yeah.
And they generally choose. It's like you're gonna get one or the other. Like don't pretend like you're not gonna get one of these. You're gonna get one or the other. That's why they make you look at both. But keep that in mind. Like that's one way to start studying for this. Is like, all right, do I know how to do both versions of that problem? Then I'm in good shape. Okay, so we're gonna look at the one on the left here first. You do not have to graph it by making a table. I mean, if this were a free response question, you could. You can do it another way though. And I guess my question to you is, let me write the equation is, do you have a way that you might graph an equation in what's called slope intercept form?
Yeah.
What do you do to graph it?
Isn't the equation like y equals x1 plus or yeah
Mx
y?
plus b maybe? Okay. So now what you gave me is the slope formula, y2 minus y1 over x2 minus x1. These would be good things to put on your note card.
Okay.
All right, so let's do you want to write that down now, or do you want to get that at the end?
Yeah, I got it down.
Okay. So let me change my question here. What is the slope and what is the b value of this line?
Is the slope 1x and the b value 4?
So the slope is the number in front of x. And it's always a number. It does not include x.
Okay, so 1.
Yes. So the slope is 1 and the b is 4. So you start here when you're graphing.
Mm-hmm.
Used to be you go to the mall and they'd say, you are here. You start at 4. Now, which 4 do you start at? The 4 down here or the 4 up there? Do you remember?
The 4 on the right.
So you actually start on the y-axis.
Oh,
So that's and that's so if this in terms of intercept, it's the y-intercept,
okay.
and that means the y crossing wherever it crosses the y.
Mm-hmm.
Okay. Now, do you recall what a slope of 1 means?
No.
So it's actually a fraction. It's 1 over 1. And the
Okay.
top number tells you how much you're going up or down. So because it's positive, you're going up 1, and then the bottom, you're always going right 1.
Okay.
So what this means is from the b value, you're going up 1, right 1, up 1, right 1, up 1, right 1. Okay, now the nice thing about the multiple choice is that you're not going to have that many graphs that look like this. You might get 2 that are kind of close, but it should be fairly obvious once you see it. Okay.
Yeah.
But we're going to do another problem like this just to shore up some of these things that I just mentioned.
Yeah.
Any questions about what we did here?
No.
All right. So let me give you a new equation. Okay. So let's say I wanted you to graph y equals minus x plus 2. Can you tell me the slope and the b value?
Would the slope be -1?
Yes.
And then the b value 2?
Values 2. So which do you start with, the b value or the slope?
The b.
The b. So you start with this b value there of 2. Start
Mhm.
here. Now the slope's a little bit more difficult this time. It's -1 over 1. You can always write a number as being over 1.
Mhm.
Okay. Now that top number tells you whether you're going up or down. So since
Okay.
it's negative, you're going down 1, but you're always going to the right.
Mhm.
That bottom number is always to the right. Always, always, always.
Okay.
But that top number is either up or down.
Yeah.
So from that b value, from that first thing we plotted, you're going down 1, right 1, down 1, right 1. We read left to right. We do a lot of things left to right.
Mhm.
That shouldn't be too big a deal to remember.
Yeah.
And you should have some sort of a graph. Well, that was not good. It looks like that when you're finished.
Yeah.
Okay. Now, if this were multiple choice, you'd probably get 4 graphs. One that's going down, one that's going up, another one going down, another one going up. You still want to follow this process of like, what is the slope? What is the b value?
Okay.
Be able to do that. Okay, so we'll come back to 85, but let's look at some slope formula problems here.
Mhm.
And look at 87 here. So you did write the slope formula down, is that correct?
Yeah.
Okay. So I'll write it down here again. Y2 minus y1, x2 minus x1. Now, a really good strategy here is to actually label these points, x1, y1, x2, y2. Now the ones they're called subscripts. So if you ever take a programming class later on in your life, or you ever see this again, they're just another way to like distinguish between the two x values. Same with the y's. So what matters here is that the 1 goes with the 1 and the 2 goes with the 2. You can't mix them, but the 1 has to go with the 1, because what this really means is this is your first ordered pair.
Yeah.
This is your second ordered pair, like that. So all you're doing is substituting these numbers into this equation. Now, my suggestion would be to substitute negative numbers in parentheses. I'll write that out here. But could you give this a try?
Yeah. So the y2 would be -2.
Okay.
And then minus -9.
So notice I'm going to put that in parentheses like that. I generally put the negative numbers in parentheses, definitely to the right of a minus sign.
Yeah. And then it would be 3 minus 5.
Okay, very good. Could you go ahead and simplify this for us?
Yeah. -11 over -2.
Try again.
Or 11 over -2.
So I'm laughing because you've done that a few times today. I mean, it's good. Like you're just changing the sign here. It's -2 plus 9 in the numerator.
Oh, okay. 7.
And yeah, I mean, what I was laughing at is it's like sometimes, like, yeah, if it's not -7, it's 7. If it's not 11, it's -11. Sometimes that works, but not always. Now, would this answer appear, or would that minus sign be somewhere else in the answer?
It'd probably be like floating in the middle of the two.
Yeah, it'd be either here, or I prefer it up top, but it would definitely would not be on the bottom. So even though you got it correct, it's questionable. All right, why don't you try 88 here on your own? Same thing. That'll close out our lesson for today.
Okay.
But go ahead and try it on your own. I just want the final answer here. I recommend labeling them as X1 and Y1.
Okay.
How are you doing on this one?
Good. I'm just doing the final part right now.
Okay.
So I got -10 over -4.
Good. So the negatives cancel. But then is there a number that goes into both 10 and 4?
2.
2. So you divide both of those by 2. I'll show you how to work this on your calculator next time. But that would be it.
Okay.
Awesome. Okay, so if mom or dad is available, I talked to your mom earlier.
Yeah. Yes.